Today, we're going to be presenting about racing cars and our teammates, our son, Tempo, Prab, and Pooh. Our main purpose is to investigate whether added resistance affects the speed of a motor by comparing two electric cars, one operating at a normal voltage and one with increased resistance and decreased current. Another objective is to complete a circuit and make LED light bulbs by using the collision between the cars and the wire. There are several theories about electricity and physics that are used in this project. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts and is applied by a battery. The relationship between voltage and current and resistance is described by Ohm's law, V equals IR. Resistance is measured in ohms. It is a measure of how much a material or a component resists the flow of electrical current. In our project, we will use a resistor to increase the resistance in a car circuit. When resistance increases, the current decreases, meaning less electrical power will reach the car's motor, which could decrease the velocity of the car.
For the first version of our cars, we started by poking a hole through one side of the ice cream stick using a soldering iron rod. Then we put a metal stick through that hole, with the end of the stick having a rubber wheel, a pulley, and a white cap to keep the distance between the wheel and the ice cream stick. Next, we put the orange cap through the other side of the metal stick and push it till it touches the other side of ice cream stick. And then do the same for the other side of the car. Finally, repeat this entire process to make the other car. The next step is to assemble these pieces together into a car. First, we had to glue the ice cream sticks to the battery holders, which would be in the middle connecting both sides of the car. Then, we had to glue the motor onto the battery holders. After that, we put a rubber band onto the pulley and the spinning part of the motor. Lastly, we assembled the switch by using glue. Repeat the entire process to assemble another car.
After testing our first handmade car, we found that it did not work properly. The motor was too weak and the structure was not too strong enough to support movement. With only 1 week left before the submission, we decided to switch to a new plan. We bought a Tamiya car kit to build the second car. For this version, we make sure that the voltage of the motor. The second car used 3-volt motor, with the first car had a 2-volt motor. According to the Ohm law, V equal to IR. Increasing the voltage increased the current, resulting in higher speed of car. As expected, the second car moved faster due to the higher voltage and stronger power supply.
Our racing car operates using a simple but effective energy transfer system. When we connect the battery, it provides electrical energy to the motor. This electrical energy powers the motor, causing it to rotate a gear. The motion of that gear is then transferred to a second gear, which is connected to a rod holding the wheels. As the rod rotates, it causes the wheels to spin, pushing the car forward. In this way, the electrical energy from the battery is converted into mechanical energy that moves the car. Now, we have tested two versions of the car. One with a lower voltage motor and one with a higher voltage motor. The key difference lies in how much energy is delivered to the motor. The higher voltage motor uses more electrical energy, which results in faster and stronger rotation of the gear system. This increased rotational motion that is passed on to the wheels, causing the car to accelerate faster and reach a higher velocity. As a result, the car with the higher voltage motor moves more quickly and finishes the track in less time compared to the car with the lower voltage motor. Overall, we found that the car with the higher voltage motor moved significantly faster than the one with the lower voltage motor. This is because higher voltage increases the power delivered to the motor in form of watts, causing the faster rotation of the gears and the wheels. As a result, the car accelerates quickly and reaches a higher speed, allowing it to finish the track in less time. This shows that voltage directly affects the performance of electric-powered vehicles by increasing the mechanical energy output. I'm gonna explain how the circuit works by drawing the circuit diagram, right? So first, we got the LED in order to light up the end of the racetrack when the car hit, right? And after that, of course, we would have our battery, right? Battery, because we need to use the battery in order to power the LED, right? You got the 9-volt variant and the 5-volt variant. I cannot find the same variant, so this gonna do, right? Please bear with me. It doesn't make that much different anyway, so yeah. And then we got our push button, right? We make it from copper tape. Basically, we connect one wires to one side of copper tape and then another wires to another copper tape, and when the car pushes down on the copper tape, it's gonna press together and created a closed circuit which light up the LED. This is the basic gist of it, right? And then we got our resistor. Well, our resistor is obviously because our voltage is different, both the 9 voltage and 5 voltage. If we don't have that resistor, I bet that the LED is gonna blow up, or at least it's gonna short circuit or something like that, which I doubt that would be good for our project, so I just add that resistor. So now I'm gonna explain how the circuit works. Well, firstly, we got the LED, right? The LED is then soldered to the resistor because, as I've said before, the battery is too high voltage, and then the resistor itself is soldered to one end of the battery, while we also poke a hole through the cardboard box that we have made for our race track, right? Poke it, yeah, like that, yeah, basically. So now we put the wires through that hole that we just created, both sides of them, right? And from then, like I've said before, we have created a push button utilizing the copper wires, the copper tape, right? Like that. Yeah. No, that's wrong. That's wrong, right? That's wrong. Okay, yeah. Like that. Especially like that. Yes, sir. Yeah. All right. So now, if we have created the push button with the copper tape like that, right? That's gonna be our car, right? I'm not that good at drawing cars, so that's gonna do, right? So here we are. And it's gonna run in 3. Oh yeah, no, that's already running. Okay. Enough. Yeah, I get it. Okay. Okay. Yes, and then it hit, and then the circuit. What's the circuit doing? And the circuit is now closed, and the electron is now running through the wires and into the battery again, which now created a closed circuit, lighting up the LED.
For the decoration, first, we decided to divide the racetrack into 2 main lanes by using red and white striped paper straws. We started by cutting the straws into small pieces and assembling them onto the middle line of the cardboard from one end to the other end. After we got 2 big main lanes, we decided to use ice cream sticks to decorate 2 sides of the cardboard by gluing them onto the side, with switching colors between cream and red. Next, we decided to make smaller lanes within each main lanes, using full-length striped straws so that we can control the direction of the cars more easily. Lastly, we cut the red sticker papers into rectangular shapes using a cutter and stick them onto the area between the ice cream sticks and the straws.
During the process of working for this project, we have been met several problems. Firstly, there were some material we ordered that did not arrive in time and delay our working progress. Therefore, we had to borrow some materials from Mr. Shenzhen and use them in our project. Secondly, our first version of cars weren't able to move at all, which might result from weak motors and incorrect assembly of circuit. To solve this problem, we switched to using a Tamiya car set and construct new cars from that, in which I already talked about. Lastly, the batteries that we ordered were too high in voltage and could not fit in the battery holders that we had. Therefore, we couldn't use those batteries, or else it might result in explosion of the circuit and cause danger to ourselves and others. To solve this problem, we had to buy other batteries that were lower in voltage and could fit into the battery holders in which we found. In order to solve this problem, we need to incorporate some of the SLO into the work. We use 3 of them, which are articulate communicators, innovative thinkers, and altruistic global citizens. For work log summary, week 1, we planned the project, create a draft car using ice cream stick and other materials, and design the racing track with a light-up finish. We also start buying new materials. Week 2, after testing that the first car failed due to the poor structure and weak motor, we tried with the Pambly, with using a Tamiya car, and rebuilt the car, adjust the motor voltage, decorate the track, and successfully set up the light bulb system at the finish line.
To conclude the result of this project, both theories about electricity in physics mentioned at the beginning of the video are incorporated into the project. And for the objectives, one of them is accomplished in this project, which said to complete a circuit and make LED bulbs light up by using the collision between the car and the wire. We achieved that by using copper plate as a conductor and connector, as Pooh has already explained. However, we didn't fully accomplish another objective, which said to investigate whether added resistances affect the speed of a car motor by comparing two electric cars, one operating at normal voltage and one with resistance from variable resistor. As explained before, because of certain mistakes, we weren't able to make our first version of the cars move, even before adding the variable resistor. Because of this, we thought that it would be better if we construct a new version of our cars and use motors that have different powers instead. This way, both cars can travel at different speeds without us having to use a variable resistor on one of them. However, we still tried to partially meet the objective by using a variable resistor in a circuit of the LED bulb on the cardboard to decrease the voltage of a 9-volt battery, in which Pooh has already explained. Overall, we're still able to make the project work at the end as we wanted it to be originally, which was for the project to be a car race contest.